In this video, I want to continue our proof of the propensity score theorem. So remember, in the last video, what we were trying to do is we were trying to show that the probability that an individual chooses treatment, given their potential levels of outcome variable, yji, and also given their propensity score, was itself independent of yji. And at the end of the last video, we'd proved that this expression on the left was actually equal to the expected value of di, given we have yji, and also given an individual's propensity score. Well, we can actually rewrite this using the law of iterated expectations in its nested form. We can rewrite this as the expectation of the expected value of di given yji, and also given the propensity score, and also given some other factor. And the other factor I'm going to choose here is xi. So that's the inner expectation, and the outer expectation we are going to condition on yji and p of xi, just to ensure that we actually have exactly what we had in the previous row if we were to sort of use the law of iterated expectations to get back to that stage. Well, if we already have xi, then we already have p of xi, because each set of covariates defines a particular propensity score. Note that it's not the case that if we have p of xi that we necessarily have xi, because the propensity score isn't unique to a particular set of covariates. But what this means is that we can essentially take out this inner conditioning on p of xi. So we're just left with the expectation of di given yji and given xi for this inner expectation. But this inner expectation is that which we encountered when we were talking about the conditional independence assumption. And remember that we are proving the propensity score theorem under the assumption that the conditional independence assumption holds. And what the conditional independence assumption says is that conditional on xi, which is that which we have here, di is independent of yji. So what that means is that we can remove yji. So I'm going to rewrite this just so that we have it in its sort of new form, which is we have the expectation of di given xi, conditioning for the outside expectation on yji and p of xi. And just to reiterate, to go from here to here, we have used the conditional independence assumption. Furthermore, we know that this inner expectation here is just equivalent to the probability that di equals 1 given xi, which is just the propensity score. So we can rewrite this whole thing again, which is the expected value of the propensity score, p of xi, given that we're conditioning on yji and p of xi. But given that we have p of xi, the expected value of pxi is just pxi, right? So we can rewrite this whole thing just simply as the propensity score. And note that this, importantly, is not a function of yji. So what does that tell us? Well, it tells us if it is the case that the conditional independence assumption is true, then yji is independent of di when we condition on the propensity score, which is what we set out to prove in the first place. So this means that we don't need to condition on the covariate vector xi, which is in principle highly dimensional. We can just condition on this scalar quantity, which is p of xi, and we can essentially use a conditional independence assumption where p of xi has replaced xi. Hence, that allows us to assume that the treatment has been randomly allocated if we condition on the propensity score.